All right, here we go. We're going to continue with 2-4. Remember that problem we did yesterday? I don't have it here, but we wrote it down. We couldn't factor it, and I said we'd find another way to do that. Well, that's what we're going to do today. All right, we're going to try to figure out how to solve that, even though it doesn't factor like we are used to factoring. Okay, so before we get into exactly how you do it, let me do a few of these so we can kind of see a pattern evolving here. We'll do about 3 or 4 of these. So let's start off real easy. What if I did this? X plus 2, and then I squared it. This is a perfect square. All right, we've talked about perfect squares before, haven't we? So let's see what it is. It's not just x squared plus 4, is it? It's x plus 2 times x plus 2, right? And I want to come up with a little pattern here. So what's that going to be? X squared plus 2x plus 2x, which is plus 4x, agreed? Plus what? Plus 4, right? Let's do another number. Let's go x plus, I don't know, 5. We'll keep them relatively small. Now, I don't have to go through this whole, well, I don't know, let's do it one more time, and then we'll see. Okay, so we distribute, so it's x squared plus 5x, which is plus 10x plus 25. Right? Got it? Let's do a minus. Let's go x minus 7. Alright, so what would this be? It'd be x minus 7 times x minus 7. Alright, let's FOIL. X squared minus 7x minus 7x, which is minus 14x, and then plus 49. Yeah? One more. X minus, I don't know, let's say, well, let's go in order. Is that right? Just make it a little bit tougher. So let's do this. It's going to be x minus 9 times x minus 9. You should see a pattern developing already, don't you? Right? You multiply those, but then you take these and add them up to get this one. Okay. So this is going to be x squared minus 18x, what? Plus 81. Right? So we know that pattern. I mean, in order to go from here to here, we take this last number, we multiply it by itself, right? Or we square it, multiply it by itself, and we get the last number. That worked for every one of those, didn't it? Okay. How do we get the middle coefficient? We took this and added it to itself, or we doubled it, right? We just took this and doubled it. Take 2 and double it. What do you get? 4. Take 5 and double it. What do you get? 10. 7 times 2, 14. 9 times 2, 18. You get it? So we definitely see that pattern. That's a pattern we've seen before. But I want you to look for another pattern. I want you to compare this number to this number. How did you get from this number to this? Well, it looks like we didn't do anything. Does that pattern hold true? No, because it's not like I went from here to here and did nothing, right? Because it's not the same thing. So, but there is a pattern to get from here to here, to get from here to here, to get from here to here. It's a 2-step pattern.
Don't you divide it by 2 and square it?
Okay, let's try that. That's good. You've seen this before, haven't you? Okay, right.
I know, but I was terrible at completing this.
So let's take a look. If you take half of this and square it, do you get 4? What's half of 4? 2. Square 2. You get 4. Let's see if it works for the other ones, though. All right, because look, if I just looked at this and tried to establish a pattern just from this one thing, I'd probably say, oh, if that's 4, then that's got to be the same thing. Does that hold true with the other ones? No. It does?
No.
Did you hear what I just said? Okay, look. If this is 4, this is 4. Are they the same on every one of these? No, it's not. Okay, so if I just had that one thing right there, that wouldn't be enough to establish a pattern, would it? All right. So what about this, though? What Aubrey said was take half of this one, square it, and see if it comes out to this. Take half of 10. What is that? 5. Square 5. What do you get? 25. Half of 14. 7 squared. 49. Take half of 9 or 18. It's 9 squared is 81. That works every single time, doesn't it? Are you with me on that? So what we're going to do is we're going to use that. For instance, what if I had something like this? What if I had x squared minus I don't know, 20x. Okay, and also look at this. Look at this. Look at the signs of the last ones. Every single time is always what? It's always positive. And it should be positive because what am I doing? I'm squaring, right? So I'm taking this number times itself. So a positive times a positive is positive, and a negative times a negative is positive, isn't it? So this last number right here should always be positive. So what if I ask you to do this? Fill in the blank. Make this into a perfect square. See, these are all perfect squares. You see it? They all come back to a perfect square. So how do I recognize if it's a perfect square? Well, if I take half of the middle one, square it, and get this last one, then it's going to be a perfect square. So fill in the blank. What's this going to have to be in order to make this into a perfect square? It's 100, right? Because half of this is 10, and you square 10, and you get 100. You with me on that? What if I did this? What if I said x squared minus, I don't know, we haven't done 8x that way. Let's do 8x plus blank, right? Because remember, you're going to square it. Well, it's -4 when you take half of it, but then you got to square it, and you get what? You get 16. You get a positive 16, right? So half of this. That's right, because you're going to square either a negative or a positive. It doesn't make any difference, does it? Okay, so that's why this is always going to be positive right here. So if I take half of this, that's 4, and if I square it, I get 16. These are all perfect squares, by the way. Did you realize that? Okay, what's it going to be? It's going to be x what? Minus 10. That's right. How did I get that? Because I always look to this sign right here. This one's always going to be positive. This is the only one that could possibly change, right? Sometimes they're positive, or right here, let's do this one right here. Look, sometimes they're positive. Let's get a different color. Right? So they're positive here and here, or they could be what? Negative. They could be minus. Now these, the second one right here, that's always going to be positive, isn't it? Right? But these could change depending. So whatever the sign is here, that's what the sign is going to be right here. Okay, what's this one going to be? This is going to be x what? Minus 4. That's right. Look, you could find this last number one or two ways. You could either take half of this. That's always going to be this number. Because look, half of 20 is what? 10. Half of 8 is 4. Or you could look at it another way. You could just take the square root of this. Right. The square root of 100 is what? 10. Or the square root of 16 is 4. You with me on that? Alright, let's do another one. What if we said x squared plus 7x? Fill in the blank. It's not quite so easy. Why? Because this is an odd number. Let's use fractions. Let's use, no. Let's use what? Fractions. We're not using mixed numbers either. Alright, we've talked about this 100 times in here, haven't we? Okay, we're not going to use decimals, we're not going to use mixed numbers. Use improper fractions. Get that out of your head. Alright? For some reason, you've been brainwashed to think that you should always use use decimals and mixed numbers. Okay, it's not easier. For this, no, I'm telling you, listen to me. Trust me on this. On these problems, it is not easier to use decimals and improper or mixed numbers, okay? It's better to use improper fractions. So, if I take half of this, what is half of this? 7 over 2. And then what do I do to it? I square it, right? That's what we did to all the others. That was our pattern, wasn't it? Take that middle one, take half of it, and then square it. So what's that going to be? No, square. 7 squared is 49 over 4. So that's what's going to go right here. Alright? That wasn't so intuitive, was it? I mean, on these, yeah, you can just kind of do it in your head. Now, what's this? What's this going to be? What's my perfect square? What's my perfect square going to be once I filled in that blank? This is going to be what first? It's going to be x, then it's going to be plus. Always look for that sign right there. And you can do it either way. You can either take half of this or the square root of this, which is going to give you what? 7 over 2. Alright? Does that make sense? Alright, so those little things that we did are going to help us solve these problems. Alright, let's actually do a problem right now. Alright? Actually, let's do a real problem, and let's see what we get. Nope, we're doing fake problems. Let's do this. No, we were just leading up to what we're going to actually do. So here's what they're going to ask you to do. This is the problem that we did yesterday. Remember that? And then it couldn't factor. Remember that? We were stuck. We said, hey, let's wait till tomorrow. Well, guess what it is? It's tomorrow, isn't it? Or it's yesterday, or it's today, depending on your point of view of what today is. All right. So anyway, here we go. What are we going to do first of all? We're going to do this, right? Now, here's the thing. You know how I had that blank right there? What I wanted to do, I wanted to fill in that blank with something that makes this into a perfect square. Well, this number right here isn't going to make it into a perfect square because watch, if I take half of this, what do I get? 2, and I square and I get, that's not 4, is it? This is not going to be a perfect square. So let's do this. It kind of seems redundant right now, but I'm going to take this number and I'm going to chuck it to the other side. You're like, well, that's what you started with. But I wanted to set it equal to 0 because that's where we normally start, okay? So it's x squared minus 4x plus blank, right? Because I'm going to make it into a perfect square. I want to figure out what's going to go there. Equals what? Let's just take this and chuck it over here. Basically, it's the same thing as what we started with. I just put a plus blank. Why did I put a plus blank? Because I want this to be a perfect square, right? Because I can solve. We just had a homework. You just turned in a homework today when they were perfect squares. So yeah, let's figure this out. What's half of this? 2. Square it, it is 4. Now watch this. I can't just arbitrarily add a 4 to the left side. In algebra, that's right. In algebra, if I do something to one side, I got to do the same thing to the other side. So guess what I'm going to do over here? I'm going to add a 4 over here. You get it? Now look what I just did. Say what? Go away? Where's it going to go? This 8 plus 4 is going to be a 12. This thing right here, the reason we went through all this mess up here is to get to this point. Look, this is now a perfect square. Right? It's a perfect square. Why? Because we took half of the middle, squared it, we got this number right here. Now we forced it into being a perfect square. So what's that going to be? We did this earlier. It's going to be x what? Minus 2. Right. Remember, it's either half of the middle one or the square root of the last one. Okay, equals what? 12. Now look at this problem. Doesn't this problem look just like what you did on the homework last night? Yeah. So from here on out, it's the same exact thing as we've always done. Right? Square root both sides. And then x equals what? 2 plus or minus square root of 12. Let's break down 12 though. It's not simplified. Yeah, I'm going to go 4 times 3 though. Okay, so 4 times 3, so it's plus or minus what? 2 square root of 3. And that's your answer right there. You can't simplify that any further. Okay, it's just 2 plus or minus 2 square root of 3. So that's the answer to what we did before. Remember we couldn't do that yesterday? Now we can. Isn't that exciting?
Extremely.
Yeah, I can tell. I can tell you're excited. Let's do another one. It's not quite as easy as that one. 9x squared minus 12x minus 1. Now we only have like a minute left, so let's watch. You paying attention? What's different about this compared to what we did before? Well, you got a 9 out in the front. Don't like that 9. So what we're going to do is this. We're going to get rid of this 9. How do we get rid of a 9? We divide it by 9. But if I remember, whatever I do to one, I got to divide everything on the left side by 9 and everything on the right side by 9. All right. So, oops. Watch this. That goes. So x squared minus 12 over 9. Let's reduce that though. What goes into that? 4 and 3. So 4/3 what? X minus 1/9 equals what? What's 0 divided by 9? 0. So look what we do now. We're going to take this. We're going to chuck it to the other side. So minus 4/3 x plus, leave a blank, right? Equals what? 1/9. Let's do this real quick. How do we get to this? How do we get this number right here? We take half of this. Watch. What's half of 4/3?
May I have your attention, please? The
For
following
what?
students, please come to the nurse's office. The
guys
following
talking to me?
students, please come to the nurse's
Yeah,
office.
or 4, 6.
Vinny Perano.
3 times. It's multiplication.
My brain is going.
Your fraction work is
Anthony
just horrible.
Barker,
Sorry, but
Andrew
watch. 2
Garvin.
goes into this twice. What is it? It's 2/3.
Ryan
2/3
Kingshill.
squared is what? 4/9. So I
Kylie
add a
LaPierre.
4/9 here, and what do I do over here? Add a 4/9 here. Okay?
Please
So
come to the nurse's office.
let me get rid of
And
this.
middle school field hockey.
This is now a perfect square. What is it?
Come to
It's
the office
x
to pick up a
minus, what do we
flyer.
do? Take square
Middle
root of
school
that.
Field hockey, please come to the main office
2/3
to pick up a
equals,
flyer.
what's 1/9 plus 4/9? 5/9. Then take the square root of both sides,
Ori Glenn to the office.
and then add a 2/3. We're almost
Johnson
done.
to the office.
2/3 plus
Nick
or minus
Lembuku
what?
to the office.
Square root of 5
Brianna
over
Lopez.
3, and that's
Thank
your
you.
answer right there.
Bang, bang.
It's not painful.
It is painful.
Look at it on YouTube, slow it down, pause it, and watch it. Where's everybody going? Nobody took my homework.